Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where I talk about everything I want to, science and math. That's how I start all my videos. And this is part 2 of Unit 1 of Elements of Chemistry for East Paulding High School. So if you are on a different playlist, if you're doing a different one, go find the right playlist. This is the one for the kids who have been absent, and now they can watch the video and find the Canvas notes and get caught up. All right, so the other video cut out and we were having the Pledge of Allegiance. So ignore the end of that video where we're pledging, and we're going to continue the notes right now. So we had gotten to here where we were talking about the base units for the metric system, and now the prefixes. So how we're going to remember the prefixes is this. King Henry's daughter bakes delicious chocolate muffins. So you see the delicious muffins. In physical science, I think I drew the princess too, but you don't have the princess, sorry. You don't get to see her, but you just get to see the muffins, which really makes me want some really good chocolate chip muffins with butter and cream cheese on them, right? Focus. All right, so here are our delicious muffins, and what does it mean? King is kilo if you're talking about drugs, right? They say kilo, it's the same thing, it's kilo. H, King Henry is hecto. The symbol for kilo is capital K. The symbol for hecto is capital H. The next one is deca, just like the club, but it's CA, and the symbol is a capital D. Oh, stop that. Doop. My thing said low battery. Okay, I'll plug you in. Don't worry. There. Now you should be happy. All right. So deca is a capital D. Then basic. What I mean by basic is gram, liter, second. Whatever the base unit is goes next. Then little d for deci, little c for centi, and little m for milli. And how you remember that is all of the little ones end in e. Deci, centi, milli. Does that make sense to you? The deca goes up here with hecto and kilo. All right, so this is how it works. Okay, I'm going to scroll up. Going over here and scrolling up. Everybody is remembering this from middle school, right? No. Good. You get to learn it again. I like teaching new things where people are, I've already learned this. Okay, so here we have a number. We want to change 4,800 kilometers to millimeters. Okay, just ignore all the scribbling. Yours should look good. What you do is you count how many frog jumps it is. So we got the king, we got the princess, we need the frog that she's going to kiss, right? One of my all-time favorite Disney movies is Princess and the Frog. She's the best princess. She has good work ethic. She looks great in green. She's my favorite. The music's so good. Love that movie. Focus. Okay, so we're here at 4,800 kilometers, and we're going to go to millimeters. So we go from capital K to little m, from kilo to milli. Everybody's good so far? We count how many times the frog hops. 1, 2, 3, 4, 5, 6. Everybody agrees? You see where I got the 6? So now we take our decimal, which is right at the end of 4,800, and we do 6 frog hops. 1, 2, 3, 4, 5, 6. For every frog hop, we put a 0 in it. In math, it's called augmenting zeros when you just add some zeros. Remember that? In long division, augmenting the zeros, great times, right? We love long division. All right, so I really like teaching synthetic division in Algebra 2. So if any of y'all get lost in that part of Algebra 2 and you need some help, I'm here for you. I'll teach it to you. All right, so anyway, you add your 6 zeros. So we have our 4,800 we started with, plus our 6 zeros, and here's the number. It's like 4,800,000,000 millimeters. Any questions about how I did that? Let's do another one.
So you just add the zeros.
You add the zeros that you augmented with the frog jumps. Okay, so let's go from 6 liters to centiliters. So we're at liters, that's our basic one, and we're going to centiliters, that's 1, 2 frog jumps this way. We move our decimal place 2 places that way, and we add the 2 zeros. Is that all right? Do you see how this is easier than the train tracks? The frog hopping? Okay, what if you're going the other way? Milligrams to decagrams. Milli is here, deca's there. It's 1, 2, 3, 4 frog hops this way. So my decimal point's going to move 4 places this way. So it's right here. I go 1, 2, 3, 4 places, and I end up with 67.9 decagrams. And this will make more sense too when you do it yourself. Okay. All right, last idea, measuring density. I always think of Back to the Future. You are my density. Okay, so we're going to do some math on this one. You got to have some real math to do, right? So we have to learn a formula. Density is a physical property of a substance. We're also going to learn about chemical properties, which is how things react with other things in a chemical reaction. Density is a property that it has all by itself. Lead is more dense than aluminum, right? You know what I'm talking about? It's heavier for its size. Well, there is a formula that goes with density, and it's density equals mass divided by volume. I had to write it with a slash instead of a good division bar because Word is not very science math friendly. But when you make division bars in this class, I want them flat. I'm a hypocrite here. I want them flat. Why do I want them flat? It's because of this. Let me show you. I have seen, remember I've done this for decades. We're not talking about how many. And I've seen people write 6 divided by 2. And in just a minute, then they've written 612 and they get the wrong answer. Because 6 divided by 2 is not 612. Do you see that? So I will take off. I'm so serious about this. I will take off your paper if you draw a slash for a fraction bar with numbers. Now you can do it with units. If it's miles per hour, you can do MI/HR. Okay, I'm fine with the letters because you won't suddenly start thinking it's a number 1. But if it's a number, I want flat fraction bars. Does everybody understand that? See, because I'm old, it's to your benefit. Many people have come before you, thousands in fact, that I've taught science and math to, and we're letting them make all the mistakes, and you learn from their mistakes. You're getting the benefit. You're not going to turn 6 over 2 into 612. All right, so the formula is density equals mass over volume. So here is a little problem. What is the density of a piece of lead that has a mass of 114 grams and a volume of 10 milliliters? When you do math, I want you to annotate it. Remember that word you've learned about how you annotate things when you read them? I want you to go through and mark what's what. The thing that has the question word is density. What is the density? So over density, put a question mark. Of a piece of lead, lead is a chemical that might be important, so I'm going to circle it. What makes word problems hard are the words. So what we want to do is get rid of all the unnecessary words so we can get to the problem. That's why we annotate. We have a piece of lead that has a mass of 114 grams. So over 114 grams, I put a little m to stand for the mass. And a volume of 10 milliliters, I put a volume over 10 milliliters. Okay, everybody understand how to annotate? So now, the next thing we do is we list our knowns and unknowns, and how we did that was by annotating. Number 2, we think of a formula. Do we know a formula for density? Oh, yes, we do. It's density equals mass over volume. Next, you're going to substitute into that formula. Let me roll this up, and I'll tell you what I mean by singing. It's more fun with sound effects. Okay. So I have a song that I sing at this point. Now, when I teach math, I have hand claps, and I have songs and dances. Yes, there are dances too. And so this is part of math that has a song. It's a song called Substitute. It's before my time, so it's before your time. It was by The Who in the 60s. And it goes like this. Substitute. So You can do the problem without singing, but you're not going to have as much fun. Now, when you're taking the ACT or the SAT, you might just have to sing in your heart and not out loud. But this is where we sing the song. Because we substitute into the formula. Substitute. So where there is an M, I write the number, 114 grams. Where there is a V, I write the number, 10 milliliters. Where there is a D, I leave it a D because now it's my variable. Just like in algebra, it's like my X. And then you do the math. A fraction bar means divide, right? So you do 114 divided by 10, and we get 11.4. And we do the math to our units too. Grams are divided by milliliters, so the unit is grams per milliliter. Yes? You get 2 passes a semester. I'm allowed to let you go if it's less than 50 minutes. You're 2 minutes within legal time. You need to write your name on the calendar that you're using your pass. Okay. Fill it out, everything but my signature, and then I'll sign it. You fill out everything but my signature. All right. And then the last thing is you have to box your answer. Why do you have to box your answer? Because I've taught for years. And one way kids will cheat, and I know you wouldn't. These were evil Cobb County kids. I'm sure Paulding County kids never cheat. But one way those wicked Cobb County kids would cheat is that they would do a problem every possible way. So then the answer was on their paper. Do you understand the method? So they didn't know if they were supposed to add, subtract, multiply, or divide 114 and 10. So they just do all of them. They multiply them, they divide them, they subtract them, they add them, all on the same piece of paper. So whatever you were supposed to do, it was there. Well, we're not playing that game. It's like, who wants to be a millionaire? You have to box your final answer. Okay, everybody understand that? Understand the rule there? Okay, let's go on up. Last idea, and we're doing awesome. Go you. I don't know if y'all understand it, but we're making terrific time. All right, look what a cute little mole that is. All right, so the other math idea that we're going to learn from this unit is something called moles. And no, it's not the cute little animal. It is a unit of measurement. So let's talk about the idea. If I go to the store and buy eggs, how do I buy them? I buy them by a dozen. And how many are in a dozen? 12. So the word dozen stands for a number 12. Do you understand that concept? Yes? Okay, if you go buy socks, how do you buy them? In pairs. So pair is a word that stands for a mathematical number 2. There's also another number that means 2. What is it? Couple. Couple also means 2. So there are 3 ways to say 2. 2, pair, and couple. That's what moles are. How we get chemicals. I don't send you to go get 12 atoms of carbon. You couldn't count them out. They're too little. So there was a guy called Amadeus Avogadro, Italian and fabulous, and he thought of this idea that we were going to measure chemicals in a unit called moles, okay? And he figured out the number for it. And so this unit that we use to measure chemicals in is called the number, and it's 6.02 times 10 to the 23rd power, right there. See that? It is called a mole. But in honor of him, it has a third name, just like pairs and couples. It's also called Avogadro's number. All right, are we okay with that? I didn't blow your mind too much with that knowledge. So how much is a mole? It's about a handful. So if I told you to go get a mole of carbon, it would be 12 grams, and it would end up being about a handful. Let's see if I can use this. I got a new toy. I'm so excited about it. Dun-dun-dun. A periodic table. Now let's see if I can change this so the YouTube family can see it too. Whoa, sorry, didn't mean to make you car sick, people in YouTube land. Oh, that's not too good. That's pretty good. All right, so on the periodic table, you will see an element. it will have a whole number. Like if you look at lithium over there, it's number 3. It has a whole number that means it has 3 protons in it. That's not what we're looking at. It also has a decimal number. That decimal number, if you go weigh that amount in grams, that's a mole. So if we wanted a mole of lithium, we would weigh out 6.941 grams. If we want a mole of carbon, it's about 12 grams. So that lithium, if you rounded it off, is 6.941. It's about 7. Do you see that? So look at oxygen. I'm going to hide it so y'all can't see. What is the molar mass of oxygen? It's 15.99999, so we're going to call that 16. What is the mass of hydrogen? Look it up on your periodic table and see. 1. It's about 1. So how will we know water? Is water on the periodic table? No. What is water's formula? Yay, you already know some chemistry. H2O. We take the elements, we look up their molar mass, and we add them up. So for water, water has 2 hydrogens, H2. It has 1 oxygen. So we list the elements vertically. I'm going to make you do it my way. I'm not going to let you write it any way you want. I want your math to be where I can look at your math and understand what you understood and don't. And if you just scribble, I can't understand your work. So you take the elements in the compound. Elements put together into a thing like water is called a compound. List them vertically. Next, on the next column, write how many you have. In water, you have 2 hydrogens and 1 oxygen. Next, look up on the periodic table and see what their molar mass is. Hydrogen is 1, oxygen is 16. Multiply. 2 times 1 is 2. 1 times 16 is 16. Draw a fraction bar, just a equals bar, just like you were in 2nd grade, and add them up. 16 plus 2 is 18. The molar mass of water is 18 grams per mole. How do we feel about that? Now, I used to not teach this until much later in the semester. And then I came here to Paulding County, and they did it this way. And I was highly resistant. This is not the way to teach this. But I did it anyway. And you know what? It worked great. The kids, we're starting with a baby step with this idea. And later we get to really, really hard ideas. And the kids, because we start with the baby steps so early, when we got to the hard thing, they did the best I've ever had kids do. Maybe it's just kids are smarter in Paulding than Cobb or Fulton when I taught there, but they did great on it. So we're going to keep doing it this way. All right, so this is how you do mole problems. First, let me scroll up so you can read it. First, write what you know, okay? And then write the units of what you know in the denominator. Wait a minute, we were going to the wrong place. Yes, think of a conversion factor, do the math. So example, how many grams are 4 moles of carbon? We start with writing what we know, 4 moles of carbon. We write moles of carbon in the denominator. A mole of carbon is 12 grams. We get that from the periodic table. They're the same thing. 1 mole of carbon is the same thing as 12 grams of carbon. Does that make sense to you? The moles of carbon mark out, and you're left with grams. You multiply any number on top, you divide any number on bottom. So it's 4 times 12 divided by 1, which is 48 grams. You box your answer. How do you feel? Nobody cried, nobody got a rash, nobody running out of the room. We're doing good. I have had kids just break out into tears every time I tried to teach them math. All right, so is that the whole thing? Did we learn all of it? Yay, go us. All right, YouTube, remember the notes are on Canvas on today's date on the home screen, so you can go find them there. Like, share, subscribe. Math is great.